We now turn our attention to a very pivotal skill that's necessary for the rest of your math career, and that is solving quadratic trinomial equations where a is not equal to 1. And the skill here is factoring those. We're going to go ahead and use the tic-tac-toe method in this class. It's a more rare form of factoring, but in my many years of teaching quadratic factoring, this is the one that sticks the best with students and that I see the most success with. So we're going to focus on this one. In the event that this is not working out for you, there's definitely worse ways to factor, and you're invited to look those up. There's a grouping method, which we've kind of talked about, but the preparation is a little bit more difficult. And of course, there's a quadratic formula, which we're going to show you later, but it's not necessary to use it if the numbers are simple enough. Okay, work with me here. Tic-tac-toe. So of course we always identify A, B, and C first, right? So for a standard quadratic, it would have coefficients of A, B, and C. And this is kind of like the AC method that we've done before, except that there's a bit more to it. There's more dimensions to it. So we put the A in the first square of the tic-tac-toe, and then the C in the second one, and then our air conditioner, right? Our air conditioner goes in this one here. Now, don't be fooled. This B is not in the last square. I'm going to make a separate box for it. So technically, I have a traditional tic-tac-toe set up with an extra box on the bottom or in the basement for B. And true to form, we're going to look for numbers. A number that goes here and a number goes here. That when I multiply them, it gives me this. But when I add them, it gives me this. Just like we did with the AC method. So we haven't really done much extra at all at this point. This is the AC method. It just looks different, but it's exactly the same thing as before. A times C goes on the top, basement goes on the bottom. Two numbers are multiplied to the top, add to the bottom. The joy comes in finding these four numbers right here. And these four numbers are all multiplication numbers. So in other words, this number times this number will give me this number. This number times this number will give me this number. This number times this number will give me this number. This one times this one will give me this one. It'll make sense once you see it. It kind of just all folds out. And one more thing I want to point out in general about this is when we look for these numbers, leave this column always positive. So don't put any negatives in here. Okay, leave this positives. If you are needing negatives, put those in the second column. If you were completely confused, then let's start here with part A. We're going to go ahead and use some numbers. So let's identify first what A, B, and C are. We'll set up our tic-tac-toe. A goes up here. Notice that I'm using my signs even if they're positive. C goes right here. A times C goes right here. The box on the bottom is my basement for my negative 12. Notice how this is not part of the tic-tac-toe. It's an extra square. Two numbers that multiply to positive 36, but they add to negative 12. If you want to think about it and pause, you could. Negative 6 and negative 6, if I multiply them, it gives me this number up here. If I were to add them, it gives me negative 12. I told you that to always make sure that this first column is positive, so let's make this positive automatically. Now, we're going to have to kind of juggle some numbers in our head a little bit, but this, once you get this, it's really nice. So I know that these numbers have to multiply to 4. The only options for that are 4 times 1 and 2 times 2. But whatever these numbers are, they have to help me get negative 6 over here. So I think positive 2 is my best bet, right? 2 times 2 is 4. 2 times something has to give me negative 6. So that's probably negative 3. And then negative 3. Are they always the same? No, this is a special case, right? It's going to be repeated roots. But look what happens here. What if I check on these? What if I multiply 2 times 2? Do I get 4? What about negative 3 times negative 3 is at positive 9? Positive 2 times negative 3 is at negative 6. And of course, is that also true? So notice how much math we did without any variables or letters. Like, I know we're doing an algebra 2 problem, but we just pretty much used numbers from elementary school. So check it out. Here's how you get the answer now, right? You go diagonally. So for example, this is going to be a 2x minus 3. That's one binomial. And then the other one is going to be diagonal as well. And you read it from left to right. So it's going to be 2x minus 3. And those are equal to 0. So again, some left column ideas you probably aren't really writing anywhere that you should write down, because it's important that you write down these words. And that's that this first column is going to be positive. Okay, don't put negatives in here at all. And then the way we read the answers or the binomials from this is from left to right diagonally. So that's why I have the 2x minus 3. And then this pink 2x minus 3. You'll see with other problems and examples how we read those better. At this point, of course, you separate and solve. And if you do that, you're going to get x is equal to 3 over 2. And x is equal to 3 over 2. This happens to be a repeated root or a double root. And so we're done with this problem. I want to go ahead and do part C. I'll let you do part B later, and I'll give you the answers for that. But let's do another one, a beefy one. This has got some pretty big numbers. I make my tic-tac-toe traditionally. I put a little box on the bottom, right? A goes right here, positive 24. C goes right here, negative 15. A times C, that's going to be negative 360. Goes right here. And then my little box on the bottom is the basement for B. Two numbers, I know, two numbers that multiply to negative 360, but if you add them up is negative 2. Honestly, this is the hardest part of the tic-tac-toe, is just figuring out these two numbers. Everything else falls into place nicely. So you might want to use a calculator to kind of toy with some numbers. Remember, when looking for numbers, you don't want decimals or fractions. You're going to get whole numbers. And keep in mind, one of them is going to have to be negative, one of them is going to be positive, right? It doesn't matter which one's which, but I'm going to just point it out right now. Because how do I know? Because it's going to multiply to a negative 360. So I have negative 20 and positive 18. They multiply to negative 360. They add to negative 2. I know these are going to be positive because it's just a good habit. And because this is going to be negative, because if I multiply them, it gives me a negative, right? And this one's got to be positive. Positive, 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 positive. Okay, let's figure out some numbers. Oh gosh, so let's do, I'm going to put a 4 here and a 6 here. Why didn't I pick 8 or 3? Because remember, 8 times 3 is 24, but these numbers have to give me this as well. And nothing times 3 is 20. Nothing times 8 is 20. Same thing with over here in 18. So we have a positive 4 and a positive 6. And why did I put them in this order? Because 4 times something could be 20. Right? 4 times 5 actually is 20. So positive 4 times a negative 5, negative 20. Positive 6 times a positive 3 is positive 18. Oh, but oh snap. Do these work going up? 6 times 4, 24. 3 times negative 5, negative 15. So again, I know with these little pink numbers right here that going up is multiplication and going down is addition. But when it comes to these purple numbers are all about multiplication. Okay? So they multiply up and they multiply side. There's no addition to worry about here. It's multiplication for the purple numbers. How do you read the binomial factorization from this? Well, remember left to right and diagonally. So this is going to be 4x plus 3. This is going to be, from left to right, 6x minus 5.
You're brilliant. You're handsome. You're rich.
Separate and solve. You're going to get a negative 3 over 4. And you're going to get a 5 over 6. And those are our two roots. This time is not a repeated root. Okay. Now, I have a daughter right now who's taking Algebra 2. And I'm not throwing her teacher under the bus or anything, but she was really struggling with factoring these quadratics. And her teacher showed her the traditional way to factor this, which is how I was taught. And it's a pretty intense, long-winded process. So I sat down with my daughter, who's a bit of a math phobic, and showed her the tic-tac-toe. And within 3 problems, she was getting it. And she no longer needs me to help her with factoring quadratics anymore. So this is going to be your 3rd problem I show you. And I highly suggest that you really go back and try out these problems again for yourself to be able to get the same answers that I got. This is a pretty useful, helpful, good, easy, solid process once you get it down. And it stays with you. So here we have positive 12, negative 3, negative 36, right? A, C, A times C. Don't forget those signs. On the bottom is negative 16. Don't get cheap on me. We have 9 spots in the tic-tac-toe plus a 10th spot in the basement. I'm going to need 2 numbers that multiply to negative 36 but add to negative 16. And that's going to be a negative 18 and a positive 2. At this point, we no longer need to worry about addition. Everything in these 4 squares is multiplication. I do need a negative here. I do need a positive here and a positive here and a positive here. Okay. And so we need a 2 going to the right, and we need a negative 18 going to the right. Let's try 6 and 2. So 2 times 6 is 12. 2 times 1 is 2. And 6 times negative 3 is negative 18. You can always check, right? All these purple numbers are multiplication only, no addition. The blue ones are addition, multiplication. Purple is multiplication. We go ahead and look at the diagonals. Left to right, 6x plus 1, 2x minus 3. The beauty of these problems, folks, is that it's mechanical. It's like the same process each time. There's no big surprises. Now, what if this process doesn't work? Well, if this process doesn't work, then the quadratic is prime. Okay, we've established what prime means. We'll do it again in this video. Prime refers to the fact that the factors are not whole numbers, or integers, I should say. We would get fractions, we would get decimals, but we wouldn't get like positive or negative or numbers at all. So if this tic-tac-toe, if we set it up correctly and it doesn't work, that means it's prime. And that can happen. If we separate and solve this, we get x is equal to negative 1 over 6, x is equal to 3 over 2, and those are our 2 roots for d. I want you to try b out. And let's set it up for you. So here's my a, here's my c, here's my a times c. So here's my a, here's my c, here's my a times c. So here's my a, here's my c, here's my a times c, here's my b bottom in the box. You're going to need to find 2 numbers that multiply to negative 4, but they add up to positive 3. And once you do that, find out these 4 numbers, make sure that these are positive, right? And in this case, again, we're going to have a negative here, okay? And yeah, or maybe we won't have a negative. Who knows, right? It depends on what you set up over here. What we do know for sure is that these two will be positive. So go ahead and roll out with it, see what you get. Once you've done all that, you should have gotten the following binomials: 2x minus 1, x plus 2. If we separate and solve, you're going to get x equals 1/2 and x equals negative 2. And then try out E. Set it up from scratch. Do it all on your own. Find those missing magical numbers. Then find those 4. Create the binomial factorization left to right diagonally. You're going to get for E at some point 2x plus 3 and an x minus 3. And it doesn't matter what order these are in. So if you wrote x minus 3, 2x plus 3, that's fine. Either of these two is perfectly fine. Just don't mix up the signs, right? We read from left to right diagonally, right? And so then if you go ahead and solve, you're going to get your roots as x equals 3 and x is equal to negative 3 over 2. For your summary, explain in words how to get the binomial factors from the tic-tac-toe chart itself.